Welcome to all to class number 52. As I told last time, the critical question which I solved last time, I will tell the question once again. Simply support beam of span 10 meter loaded by UDL of 20 kN per meter over entire span and one point load at a different position I considered. I solved 7 questions. All these questions are solved in 48, 49, 50 and 51 class number. But I told you one thing at that time. Some more important concepts and powerful principles are going to come. That I will explain here now. And this time I will not explain any calculation. All are thoroughly over. Those principles I am going to tell one by one. And remember, I written here, concepts explained in this class are very important throughout this course or now onwards. This principle what I am going to consider today or concepts will repeatedly come. That time, if it is not clear, it is your mistake of not going through thoroughly this class. So have patience and go through everything. Correctly understand. Better once again solve and get the grip. Okay, now I'll start now one by one. See, that is first one. I'll put the beam here. See, I'll operate in this space now. Everything I'll operate here. This will remain same throughout this question now. See, this will remain same throughout. How much it is? I'll put somewhere here. It is 20 kilonewton per meter. Actually, there's a problem there because I want to bring it little down. Otherwise, it may overlap. Later, when I change the point load, it will overlap. No problem. These are all nothing to worry. See, I'll put here. Safe. Now, no problem now. Correctly I will draw. Point A, point B, UDL. Okay. Little more. Span I will not write here. This is a space for VA. As I change problem to problem, I will change the values. This UDL is somewhere I'll write here once for all 20 kN per meter. And then one by one point. First question 3 meter from A. This is 10 meter. Somewhat scale I will maintain. 3. Okay. Load is 50 kilonewton. This is 3 meter. And this is 7 meter. 7 meter. Okay. I will start solving. See, I am not going to see the solution earlier and solving once again. So you also solve simultaneously. In case by chance, if there is any calculation mistake, is there, correct it. I will be careful. (115 kilonewton). Tooth 135 kilonewton. Over. Reactions over. SFD, somewhat to scale. 135 down by 60, 75, down by 50, 25, this is 75, this is 25, again down by 140, 115, 135, 115. You can see how I am solving also. 115. This point required, you already know how to locate that point from both ends. 5.75 meter. I am rounding off because calculated minus 7 is 1.25 meter. Now important starts. See, bending moment diagram. I am not even writing SFD BMD here. Why? All written. Bending moment diagram. See SFD, left up, right down, positive. Sign also not required, plus and minus. And then BMD, bending moment sagging positive. That's all not required. So bending moment here required. $315 here. Here $315. Some scale I will write $315. And this point you require bending moment. That is directly I can put. Without locating I can calculate. It is 330.625. See, 315 little more. 330.625 is the BM here. Now, important is C. A to C parabola. This is B. B to C parabola. This wherever is this point load is there, it is called C. So now onwards, I want to explain for all 7 questions, A to C parabola and B to C parabola. A to C it is a single parabola or a parabola which should have only one equation in terms of x. B to C also same thing. Even if it comes up and down, see, it may come up and down, but expression for BM is in terms of x at x from here will be same for any section between BC. Now, see here. Here, shear force 135. Here 115. Therefore, you already know rate of change of bending moment equal to shear force. Therefore, here BMD will have little higher slope. Here lesser slope. And here shear force is positive, there negative. So, after drawing tangent to bending moment diagram, when you mark the angle where shear force is plus, if the angle comes this way, when shear force is minus, angle will come this way. Why? Because of different signs. Okay. Now, and now as I told, little more steep here. See. But here, shear force is 135, here 115. So, how much, see, if I draw a tangent here, this slope will be 135. Here, no, it is lesser. But what happens is, from here, see, one curve. From here, different. It will go this way. And then, one more thing I told. To the left of this point, shear force 75. So, if I draw a tangent here, slope is 75. If I draw tangent this side, slope is lesser, 25. It should become flat. So, see. Okay, reasonably okay. I will put little this side. It should come little higher here. Okay, okay. It will come this way. So, this is the peak value. How much? And if you draw a tangent here, the slope should be 0 because shear force 0. And to this curve, if I draw it, if I exaggerate here, it looks like same because it should be actually little, yes, correct, okay, see. Okay, I will make it more steep. Now better. Now better, see. If I draw a tangent here, slope is more. Tangent to this one, slope is lesser. This I already told, plus. Now, one small principle. See, suppose I find bending moment here at, oh no, I will do it later example, not now. Later example, I will show it more clearly, not now. The last example, it is the best. Okay. This is a bending moment diagram for your question number 1. I'll keep on continuing. Question number 2. Load at 3.6 from B. $50 kilonewton load. (3.6 meter). This will be 6.4 meter. Somewhat to scale. 4 meter. This is the point C. Reaction will change. (132 kilonewtons here). 118 kilonewton here. 132 here, 118 here. Check. Just check the answer. Yes, correct. Shearing force diagram. Go up by 118. Okay, this I should not explain now because why? These are all already over. 118 minus 20 into 6.4. Minus 10. When you reach here, it becomes minus 10. Correct? 20 into 6.4 is 128. Correct? Minus 10. So SFD will cross the baseline before C now. Okay, reasonably okay. Straight line 10. Down by 50, 60. Again we'll go this way and reach here. It is 132. Plus minus. This point required. From here to here sufficient. Other side not required. It is 5.9 meter. So automatically this will become 0.5 meter, not 0.5. 5.9 minus 6.4 is S.5 only, 0.5 meter. Now, bending moment diagram. Observe now. Baseline. You need bending moment here. (345.6) is the bending moment here. 345.6. Here bending moment required. Directly I can get. I don't require location. 340, something wrong. 348.1. I got doubt. 348.1 correct? Huh? I think little more. 348.1. I check. 118 into 5.9 minus 20 into 5.9 into 5.9 by 2. 348.1. Okay. Or if I do from that side, safer side, 132 into 3.6 plus 0.5 is 4.1 minus 20 into 4.1 into 4.1 by 2 minus 50 into 0.5. What is this? 132 into 4.1 minus 20 into 4.1 into 4.1 by 2 minus 50 into 0.5. 348.1, correct? Now, see. Here to here, one parabola. Now here, shear force is more here, shear force is less here. So, this parabola should be more steep. Why? Because slope is more. This here, parabola should have slope lesser than that one. And here, it will keep on increasing, reach the peak value, come back here. See, if I do a tangent to parabola here, slope will be 60. But this side ending part, slope should be only 10. So, it's a very, see, compare this value, very little more. So, what will happen? Now see, came beautifully. So, this is 348.1. Now, see, this tangent angle will be 60. This tangent, it should be a little flat, now, little flat. Okay, it will come this way. This tangent, actually problem, okay. Angle should be lesser, it should be only how much? 10. Okay. Now, see, 0 bending moment here, parabolically increases, directly increase here. Here, it increases, it reaches the peak value, then again drops down, little problem. Okay. This is a bending moment diagram for second example. Now, 4, 3 and 4, very easy it will be over, 3 and 4. I am rubbing because these are all over. Any day you can go and refer previous class. important concept will come little later. Actually, it's coming slowly now. 4 meters from A. Okay. 50 kilonewton. I told by chance if I made any calculation mistake, do not make an issue, correct it. But I am be careful. Okay. Reaction. $120 kilonewton. 120 kilonewton. VA 130 kilonewton because total 250. This is the point C now. Shear post diagram. 130. When you reach here, it correctly comes to 130 minus 20 into 4 is 50. Oh, this is actually it's a coincidence. It never happens usually. 50. Then down 50. Oh, 0. Then here 120. Here, the location of point is not there because it is a known point where shear force 0. Now see important. This is the point where shear force is 0. It is 0 to right side. So, the bending moment diagram should have 0 slope on the right side. Left side, you should have a slope of 50. So, what will happen? First, I need the maximum BM here. $360. Safer side, I'll check from that side. Actually not required. 360, correct. See, now very important, this side the slope should be 0 here. So, see, it will go this way. If I do a tangent here, 0 slope. But this side slope should be there. Now can see, if I do a tangent here, there will be slope. So, this is the bending moment diagram. This all I already explained earlier. So, just repetition or once again giving information for the concept so that later there is no difficulty. Okay, this is also over. Sign all I am not writing. Now, fourth one. Sorry, I forgot to write question number only here. Okay, next I forgot to write that one. Adjust it. Next, fourth one. Same here. Load here. $50 kilonewton. This is 6 meter. This is 4 meter. Now reaction. This will come 130. That is okay. This will come 120. Shear post diagram. Up by 120. Down by 20 into 6. Correctly, it comes 0 here. See, now left side is 0. Right side, it will be 50 here. 120, 50. Plus minus. Here, 130. I don't have to calculate bending moment because it will come same as last time. How much it came last time? Who remembers? I have to do once again now. See, that's how I already told. I am very weak in remembering or by hearting. 360. 360. See, now important. This side slope should be 0. That side slope should be 50 or there should be slope. And here slope should be lesser. There slope should be more. So this side it will be steep curve now. See. If I draw tangent here, there will be slope there. But this side, see. Yes, see. If I draw tangent this side, slope is 0. And here, this slope will be 130, whereas this slope is lesser, it will be 120. Okay. Now, 4 over 5. I think I remove this one because too much of that marks are there. Once again I will write. 5. 5 is, I remember, it is central load. Sorry, I should first put UDL. Otherwise, it looks very odd, awkward. (20 kilonewton per meter), central load of 50 kilonewton. 1 minute. Let me see the camera once. I do not want that load not visible later. Visible. Okay, okay. Otherwise, full what I told gets wasted. Now reaction, no need of calculating. Total 250 kilonewton. So each reaction will be 125 kilonewton and 125 kilonewton. Distances are 5 and 5 meter. Little out of scale, manage it. 5 meter, ABC. ABC. Shearing post diagram, see. Up 125. 20 into 5, 100. 25. Here, again 25. Here, 125. Little more. Okay, okay. 125, 125 plus minus. Bending moment diagram. See, I am not very neatly projecting. Principle is more important. You should not find fault that if I look here, slightly point it this side, that side. Though that only people who are the habit of finding mistake, they only will do it. Those who want knowledge, they will never bother about those things. This is, I can directly do it. 20 into 10 square divided by 8 plus 50 into 10 divided by 4. You don't bother now. It will be 375 because it is a formula. 375. Okay, now 125, 125. So slope here should be slope here for tangent. Here also, this side, slope 25. This side, slope 25. Slope is not 0. So that means how steep is this? Same should be this steep. Means whatever is this angle should be this angle. And whatever angle this tangent makes here, same angle this tangent also will make. Okay, over. See, I told. Okay, once again. I'll rub and write because next will be fractional values are there. That is the sixth one. Sixth one. Sixth one and seventh one, I will tell some important AB, concept point of view. 4.2 meter from A. 4.2 meter from A means somewhere here. Okay. 50 kilonewton. 20 kilonewton per meter. 4.2 meter from A, that is 5.8 meter. Okay. 5.8 meter from there. ABC. Reaction required. Actually, I can make a note and write it and I could have written and bought. But no, I never believe in written solution. I always calculate. 121 kilonewton, VB. VA 229, no, 121 minus 250, some calculation problem. VA equals, see, I can make out immediately 129 kilonewton. Immediately I can make out. Okay, now this question I am going to tell some principles, learn it. Up by 129, down by 20 into 4.2. 45. If you remember, these all came last class. 45. Okay, somewhat okay. Down 50. It will go down very small value 5. Minus 20 into 5.8. 121 here. Now see, important concept. Plus minus. Shearing post diagram is crossing the baseline under the load. But shear force is not, that actual zero is not there. This side is, how much I told? 129 minus 20 into 4.2. I forgot, right? 45. This side shear force is 45 plus that side minus. Now, bending moment diagram. See, this point BM you require 365.4. That's all. Calculate it later. 365.4 here. I'll put somewhere here 365.4. Now, see, this is actually 4.2, this is 5.8. BMD, this side shear force 129. So, that side 121. This should be more steep, that should be little flat. Even after reaching here also, this side 45, that side 5. So, this side here and here both little flat compared to this side. So, this will be more steep. See, more steep. This will be little flat. How much angle here? See. Okay. Or, see, if you draw tangent here, this angle will be 129. This is 121. If I draw tangent here, little this way tangent. Okay, tangent here. This will be 121. And if I draw tangent here, this side, it will be 45. This side tangent will make lesser angle. Now, one small interesting point for you. I will find BM from center to either side by not much, say 0.2 meter. Round number will come, 0.2 meter. In the class I will ask question. Tell me, 0.2 meter if I come left side or if I go to right side, I will ask, tell me where maximum will come. Then they will tell, sir, we have to calculate. Don't calculate. Use concept. I already told you, this is what more steep here. This is little flat. Since this is little flat, slope is lesser. As you go this way, BM will be still more. Here, BM reduces rapidly. Therefore, 100% the BM at 0.2 meter this side, little very close by. If I mark at 0.2 meter from this side or at 0.2 this side, 100% this value will come more, this value will come lesser. Let us check it now for understanding. If it is 0.2 meter here means from here to here is 4 meter, the bending moment. 129 into 4 minus 20 into 4 into 2 will come 356. There, it has to give less than 356, correct? Why? It has to come more than 356. Why? Because I told this is little steep. Steep means drop is faster. This is little flat. Therefore, this has to come now more than 356. Let me see. If it is 0.2, this will be 5.6 meter. That is 121 into 5.6 minus 20 into 5.6 into 5.6 by 2 is 364. See there? 364. That is 364. That is the bending moment. In example 7, reverse will take place. This will come 364. That will come 356. Center, this point will come same, 365.4. This side shear force will come how much? 5 means 5. That side will come 45. Therefore, here the slope will be little, next time lesser, here slope will be more. Okay, now lastly 7th one. Roughly I will draw. Very roughly. How much it is? 5.8 from here. See, once again, usual problem. I should have noted down the values, forgot note down, no problem. 5.8 meter and 4.2 meter. Reaction, I will calculate once again. I won't use ABCD now. I won't use ABCD also this time. 50 into 5.8 by 10 is 50 into 5.8 divided by 10 is 29. 129 kilonewton here and 121 kilonewton here. SFD 121. When you reach here, 121 minus 20 into 5.8. 5 plus 5. Then minus 45 here. It will go to 129 here. 129. Now, draw BMD. That BM, how much you got? 121 into 5.8 minus 20 into 5.8 into 5.8 by 2 is 365.4. 365.4. Okay, now, this side slope should be lesser. That side slope should be more. And see here, again here also, this side slope lesser, it becomes flat. That side slope 45, little steep. So this time this side steep, slope more. See, this slope will be equal to 129. Here this slope will be equal to 45. This side not that way. If I draw tangent here, this slope will be only, how much it is? 5. Whereas here also, if I draw tangent here, this slope will be 121, not here 129 more, here lesser. Again now, just to understand, 0.2 meter either side, 0.2 meter either side. If you find bending moment, okay, once again I will tell the concept. This side is steep. See, steep means drop is fast. This side is little flat. Drop is lesser. So this BM should come more than this BM. This is higher. This is lesser. Check it. I forgot the number last time. If I come by 0.2 meter here, then it will be 5.6 meter. 121 into 5.6 minus 20 into 5.6 into 5.6 by 2 is 364. I don't remember. I think we got 364 here. That side, 0.2 means 4 meter only. 129 into 4 minus 20 into 4 into 2. 356. Yes, see, I told that should be lesser, this should be higher. Answer came. Now, all these points we are going to use when you draw BMD later. That is, those who are serious and want to learn everything, these are all required. If you just want to draw the diagram, I am helpless, you can draw whatever way you want. But I told my course will be systematic. So all these points will carry forward for the further classes. Okay, now next class number 53, I will come to once again simply support beam UDL with not 1 point load, 2 point load. After completing that one, I will go to partial UDL with point load. Now then series of questions will continue. Okay, thank you. See you in the next class.